This is A2Pure, we're in Unit 4 and we're looking at integration by parts, so just running through then a few examples. So our integration by parts, we need to let something equal to u, and in this case we're going to let u equal x, and then we're going to let dv by dx equal e to the x. For our formula we need du by dx. Differentiating this, of course, you get 1, and then integrating e to the x, we of course then get e to the x. So let's look at our formula. It's the integral of u dv by dx with respect to x equals u v, take away the integral of v du by dx. So let's sub in then what we know. We've let, of course, this equal u and this equal our dv by dx. So if we sub in what we have here, hopefully we end up with an easier integral than we had before. So uv is x e to the x. Take away then the integral of v, which is e to the x, and then times by 1, which is du by dx. And all we have now to integrate is e to the x, which is much more straightforward. That gives us x e to the x minus e to the x plus c. And that's us done. We've changed a fairly tough integral into a straightforward one. Down at the bottom of the page it says something quite important here. It says the choice of u and dv by dx is very important. If we change the above example we would get this. So what they're saying is it's nearly 9 times out of 10. If you see an x there, you let that equal u, because if we had this the other way around, we would have an e to the x here, and then you end up with the more complicated integral actually to work out. So the choice of your u and your choice of dv by your dv by dx is pretty important. You need to get them right, otherwise things get more and more complicated. Let's take a look at our next example then. So very similar. We're going to let u equal x and our v equals, our dv by dx equals cos x. Du by dx is 1, and then our v is of course going to be sine x, because we remember differentiate sine you get cos, so if you integrate cos then you're going to get sine. Subbing it into our formula, uv is x sine x, take away the integral of v du by dx, so it's v du by dx here, so it's sine x times by 1 dx. That gives us x sine x, and then take away, if you integrate sine you're going to get minus cos, so it's a minus cos plus cos x plus c. And of course gives us in a more straightforward one then just to work out. So that's going to work out for that. Let's take a look at our next example. X sine 3x, reasonably similar one again. Hopefully we're reasonably comfortable with that. So we're going to let u equal x, dv by dx is sine 3x. Du by dx is going to be 1, and our v, whenever we integrate this time, is going to be minus a third cos 3x. Substituting in then to our parts formula is going to be uv, so it's this times this, so it's going to be x upon minus a third cos 3x, take away the integral of minus a third cos 3x times 1 dx. Tidying this up is minus a third x cos 3x, and I suppose using a vaguely similar wee formula from here, that's a minus minus, which gives us a plus, but remember then if you're integrating your cos you're going to end up, let me see this, get this the right way around. So that's a minus minus, so whenever you integrate here we're going to end up then with our plus. So if you integrate cos you get a positive sign, so it's going to be plus a 9th sine 3x plus c, and I'm happy to leave it then like that. Next example. We're doing this example on purpose. Just when you think you know what's going on, there's always something more to confuse you. As I said, 9 times out of 10, you're going to let u equal the x, and the other one then equal the dv by dx. However, this is a special case where it's actually easier to go the other way around. So we're going to let u equal ln x, and I've actually written in the notes, note the choice. So you should write that too, just to remind you that this one's actually the other way around. Our dv by dx is x. Differentiating here, if you differentiate ln x, you get 1 over x. And integrating this, we get a half x squared. So uv is a half x squared ln x. Take away the integral of v du by dx, so it's a half x squared upon 1 over x dx. So that tidies up nicely for us. The deal here obviously is you want to make it an easier integration. That's exactly what we've done, so we're in the right place. And that gives us a half x squared ln x minus a quarter x squared plus c. Final example here in this video then, let's take a look at example 5. Again, another quite strange looking one. The thing that's weird about this one is it looks nothing like a product. It's not two things multiplied together, so you would never really expect it to be used kind of integration by parts, but it says this is one of a small group of intervals which is found by taking dv by dx to be 1. So if we let u equal ln x and pretend it's multiplied by 1, and we have dv by dx equals 1. du by dx, much like our last example, is 1 over x, and then v is going to be x. So the integral of ln x is u v, so I'm going to write that as x ln x minus the integral of v du by dx, so it's x upon 1 over x dx. Nice and straightforward here, the x is cancelled, so it's just 1 that I'm integrating, and so we get x ln x, take away x plus c.